play the audio. Okay, everyone, can we get mic checks? Mic checks.
Test. Check, check. 1, 2, 3.
Coming through loud and clear. Schrodinger's cat. Check, check. Schrodinger's cat.
Yeah. I'm here. I'm trying to work out the audio with Mandy. Yes, I'm here.
Cool. Rachie, you there?
Yep, I'm here.
Good,
Can you
good.
hear me? 1, 2, 1, 2.
Yep, we can hear you. Coming through loud and clear.
Cliff, you probably need to mute the stream on your computer.
Okay, about 20 seconds before we switch over.
All right. Getting excited.
Okay, going live in 5, 4, 3.
That's where you're supposed to talk, Cliff.
Oh, I thought it was going to be.
We're
live.
It's all you, man.
My apologies. I was desperately trying to work out some bugs that we had in the system. So hello, everybody. We are here for a debate tonight with Rachie 50 and MCToon on our new channel that is going super well so far. In spite of the bugs that we're desperately trying to work out of the system right now. So for tonight, our format is, and let me pull it up real quick. It is, so we're going to do 5 minutes for each interlocutor with no evidence, just 5 minutes each. If they need that long, probably won't. Just say who you are, what you're all about, and why you're here. And then we will move on to 5 minutes each with evidence, and then a 5-minute rebuttal for each. And I guess beyond that, we'll get to it when we get there. So I guess who wants to start? Toon or Rachie? Who wants to start?
Toon can start first.
Oh, that seems unfair to put. That's okay. I'm kidding. All right. Well, we both get to introduce ourselves before we do that. So I am MCToon. I have my own channel where I mostly debate flat earthers and 5G stuff. That's the bulk of my content. I am also the co-creator of this channel, but today I'm just a debater. I'm not a host. I'm not a moderator. Even in the live chat, you'll see that I am not. I don't have a wrench in the live chat. So I am up here with Rachie at this moment. So that's it.
Rachie.
Okay. Yep. And I am Rachie 50, and I'm here basically to debate MCToon, and I'm a flat earther. And that's about it.
Well, that was pretty quick. But if I may ask, because it's a question that I have, what are the 50?
Well, I tried to just type in Rachie, but it was already taken. And then I tried all different numbers, and that was all taken. So I just decided to type in 50, and that wasn't taken. So I had that.
Because I mean, that was my grades in my senior year of high school. So I just didn't know if, I thought you beat me out. Okay, so I guess the next step, that was pretty quick, was a 5 minute of actual evidence from each party. Who wants to begin with that? And then, it'd be a five minutes of evidence, and then a 5 minute rebuttal, and then 5 minutes from the other party.
All right, I'll start. Okay. Craig, I'm gonna share my screen so people don't know yet, Craig FTFE is producing for us tonight. So, all right, here goes sharing my screen. So one thing that flat earthers are constantly asked and never get to answer is, do you have a map? So what I'm going to do today is, that's the wrong one there, Craig. I am going to make a map for flat earthers. I will use one observation, that is the observations on the day of the equinox on the 20-degree east line of longitude. Just that one thing, that one position or line of positions. And it's going to be just for the sunrise and just for the sunset. That's it. Everything else, I'm just going to match and force the map, just figure out the map from there. So we see on the equinox, the sun rises almost exactly due east, right there, as seen from the equator. It's also due east everywhere within a very small tolerance. For the most part, if you see from like timeofday.com or suncalc.org, it shows the first appearance of the upper limb of the sun, not the geometric center of the sun. So if you do the geometric center, it's much closer to 90 degrees. But there it is, 90 degrees all the way north and south along this line of longitude. And I use that line of longitude because it's one of the longest lines of longitude that is all like that has land under it. So people can go there and check it out themselves. So here is just the one thing. The sun rises due east on the equator, on the equinox at 20 degrees east. Up in Sweden, and even up in the islands north of Sweden, it's 90 degrees due east. And this is showing a little bit less than 90, which doesn't help flat Earth, but it's okay. It's okay. And then all the way down in Lagos, South Africa, 90 degrees due east. So the problem is that that's not pointing to the same spot. You can't have multiple suns. There aren't multiple suns. There's just one sun, unless there's some explanation for it, but it doesn't seem to work. Anyway, so we have, it points to the wrong spot. So what do? Well, we have to curve the entire line of longitude so that everybody on the line of longitude simultaneously can look due east and see the one sun at the moment of sunrise. And in order for that to happen, the geometric proof there is Euclid's Book 3, Proposition 18, if you want to just reference that. Also, because the sun sets due west, you have to do the same thing for sunset. So that's what we have. We have sunrise and sunset. That's the map that is absolutely necessary for flat Earth to match that simple observation. Which also requires somehow for the Earth to undulate underneath everybody without them noticing many thousands of miles from sunrise to sunset. But I'm sure that's not a problem at all. But that is the only map that works for that one particular thing. Now, on a flat Earth, of course, on the globe, it totally works. It's actually predicted, and you can see here, this is the Earth on the equinox. There's 2 equinoxes a year, so this would be the Earth's axis tilted either towards or away from the camera. So it matches observations. It's a fantastic thing. So flat Earth either undulates by that huge amount, or maybe it just doesn't work. And the globe works perfectly. And that's what I have. So you can, Cliff, you can end my time and we can move on.
Yeah, you had about a minute left. So we will go to a 5-minute rebuttal from Rachie. Let me reset your time. Back to 5 minutes, and let me know when you're ready to start, and I'll click start.
Okay, I'm ready.
All right, and you are started.
Okay, so is using the longitude from the globe, and how it's laid out on the globe would not be how it's laid out on a flat Earth. So it's kind of like irrelevant how he's laid it out and tried to curve it like that, because that's not how it would be laid out on a flat Earth. So because obviously he's working from the globe to get the longitude, and that's basically all I got for that.
Was that it?
Pretty much, he's using the longitude from the globe, so it's obviously not going to work on a flat Earth if you're using a globe, is it?
Okay. So I'm assuming that you're ready for your 5-minute presentation.
Oh, no. Now
Yeah.
it's our 10-minute talk on this particular topic.
Oh, yeah, that's right. We have a 10-minute. Let me set the clock for the 10-minute open discussion about that, and then it'll be Rachie's 5 minutes, and I will begin in 5, 4, 3, 2, 1, start.
All right. So could you send the correct map for flat Earth then, so we can test that?
I cannot at the moment, but I have got some ideas again on how you've basically transferred it from a flat map to a globe. So I'm trying to reverse engineer that, shall we say.
Well, that's what I did. That's pretty cool, though. So what I did is I didn't actually start with the globe. I started with, there are people along a certain position that see the sun simultaneously. It just happens that it's a line of longitude on the day of the equinox. And since they see the sun simultaneously and they all see it in a certain direction, all we need to do is cross-reference everybody so that they can all look at the one sun at the same time, using Euclid's book 3 proposition 18 to face the correct direction. It made no assumptions about the shape of the Earth other than flatness. That's all I started with.
Okay, but like you say you use Euclid, so obviously you use flat because obviously Euclid is 3 dimensions, not non-Euclidean. But how do you know exactly where they are? So like you've got a straight line on the globe for the longitude on the equinox, like, but what's saying it's exactly a straight line like that on the flat Earth?
Oh, I didn't assume a straight line or a flat line. All I assumed was flatness, and so it was the people and the observations on that particular line of longitude. Call it whatever you want, but it's a position on the Earth. They all can see simultaneously the sunrise. So they all have to be facing due east towards the sun. Right? It's just a deducing how they have to do things. So that line that they're on, that all of the places that see the sun simultaneously on the equinox must be curved with a radius equal to how far away the sun is from them. And we know that because we know the subsolar point on that day, and we know how far away it is. It's about 10,000 kilometers away on the equator.
So you're saying people in the UK and people in, like, say, the bottom of Africa or like slightly down towards Australia would all see the sunrise at exactly the same time?
Along the line of longitude. Yeah, on the equinox, everybody does see. From the top
to the bottom of the globe, like if you imagine the globe a minute, from the top to the bottom of the globe from the UK, if you draw a straight line straight down, they'd all see on that longitude the sunrise at the same time.
Yeah, whether it's a globe or flat, there's a line, and everybody sees simultaneously the sunrise.
But what about if the Earth was a globe, just presuppose in a moment, wouldn't it be on a tilt, so therefore it wouldn't all rise at the same time?
Actually, no. I can show you here the tilt. If the sun's here, this is a solstice, right? But if we do this, here's the tilt. You can see it's tipped away from the camera. And if the sun's over here, it's going to be, and I can actually put this around. This will help. This is a line of longitude right around here. So if the sun's, let me tip it right there. If the sun's right there, it's going to illuminate this entire line at the same time as this entire line passes into sunlight. Right?
Okay, I did not realize that.
Yeah, that's the tip. You see, here's the tip here. So if you ever see this, This is the tilt of it. That's why they're always like this. It's not because it's artistic. It's because it's the actual tilt of the Earth. There you go.
So on a flat map, if you was to create one, you'd have to have it where the sun rises for all of them on that long line of longitude for the same time.
Yeah, and also facing the sun at the same time. And that's why I made that curved line of longitude, because it matches the observation and it's flat.
Okay, is there any other way that it could be rearranged where, you know, it still works? I mean, you said you've done it with the curve and it works. So what exactly is the problem?
Well, it does work. That particular curved map does work. The problem is that that sunrise and sunset are drastically different. And so it has to curve from here, and then the actual Earth has to undulate underneath everybody over the course of 12 hours and be shaped this direction 12 hours later. Of course, all of the Earth has to be doing this for everywhere along, so that happens every day of the year. And so we'd have to be moving like that. So is it reasonable to think that the Earth moves, like actually changes shape underneath us to the tune of thousands of miles over the course of several hours? Or is that a little bit of a bit of a stretch to think is what's happening? Because I can't make that particular observation match any other map layout.
Well, yeah, it would be a bit of a stretch, obviously, but what about the movement of the sun? Wouldn't that be able to, you know, be a factor in that too? If you change the way the sun moves, kind of thing, like, you know, the path that it takes, kind of thing.
Yeah, it's possible. I'm just, to keep it simpler, because it as soon as we add in additional observations, it complicates things because you need to add more and more observations in. And this one observation, just the sunrise and sunset angle at the moment of sunrise and sunset for those on that the 2 days a year, that's it. And it's a pretty far stretch to think that the Earth would do that. So the question to you is there any other possible way that the Earth could be organized like that? I've not been able to figure it out. That's why I cited Euclid's postulate, because it's kind of a necessity. So, or some other, you know, evidence-based explanation for how that happens.
Well, I suppose without an actual flat Earth map and the way the sun actually travels, you wouldn't be able to really say, would you? So, as like I said, I am going to work on a flat Earth map. I do believe there is a way to actually, that basically they've changed it from a flat to a globe, and I believe there is a way to reverse engineer it back. But obviously, I haven't got that at the moment, no. But obviously, you say that the Earth would have to undulate, but if you take into account the movement of the sun, because obviously in the globe model it's not moving, but in the flat Earth model it would be moving. So therefore, if you take into account the movement of the sun, maybe that could, you know, fix it.
Well, I was just, the movement isn't really that important because I'm just looking at the moment. Just one moment is all we need to look at, not even 1 minute difference or 2 minutes, right? It's because the sun appears to everybody along that line of longitude within a very short margin of error. It's the movement doesn't matter from you know, from sunrise to an hour later or 6 hours later or 12 hours later. It's just that one moment, and everybody can stand. If everybody held hands and stood along the line of longitude facing east and simultaneously saw the sunrise, in an act of unity and harmony, that's what would happen. They all have to be looking east at the same time towards the same one point. So that line has to be curved in order for everybody to be able to see it due east at the same time.
Would it be the same on the globe as it is on a flat Earth?
On a globe, it is curved, like I showed. I'll show you again. This.
Yeah, but I mean, like, would
right,
it be the
that's
same
curved.
direction?
Yes, yeah. So here is this. This is the Terminator line, right? Not the Schwarzenegger Terminator. And the sun's over here, and it illuminates everything on this half because the sun is bigger and tiny bit more. But yeah, you have your twilight along this line here. So it works well. It's predicted on the Earth, and actually you can take, and I've done this before, take a globe and put it on a table and then put far enough away that you get a pretty good distance from it. Okay. Put a light there and see how much is illuminated, see if it matches observations.
So the only rebuttal basically I've got today is I will have to get back to you when I've tried to get a flat Earth map together. But at the moment, I can't really say, but I do think it would be able to work on a flat Earth. That's pretty much all I got for now.
Cool.
Okay. Yeah. Good timing. I do have to push back a little bit. The Schwarzenegger Terminator 2 is the only real Terminator.
Duly noted.
Yes. So I think, correct me if I'm wrong, we're going to go into 5 minutes for Rachie to present evidence. I think that's the very next step, unless I'm wrong. And I did work out the questions. I have the questions piece worked out. So when we get to that part, we're all good to go. So Rachie, are you ready for your 5 minutes to present evidence for the flat Earth?
Yep. Well, it's not really for the flat Earth because like MCToon wanted to do it on that, and MCToon wanted to do it on the moon landing, so it's more about the moon in the first place.
That's perfectly fine.
Yeah.
So give me a 3, 2, 1 count, and I will click start.
Okay, 3, 2, 1.
All right, go ahead.
Okay, so my first claim is that the moon self-illuminates. It should be seen during the new moon, and the moon landings never happened. So during the new moon, the Earth shine should illuminate the moon. The excuse is that we can't see the moon during the day, because obviously it's daylight. The problem with that is that we can see the moon during the day. Another reason we should see the moon during the new moon is because the moon self-illuminates. So in the link from NASA, it says, to quote part of it, as limited time, it says it's demonstrating that the moon literally glows in the dark when there is no sunlight or earth shine. Now, onto the moon landings being faked. I'm sure most of you have heard or seen a funny thing happen on the way to the moon, where you can literally see them faking the shape of the Earth through the window. Among the other things in there, like the timing of the moon landings, how it's long it took to get there and get back. Not going to suggest playing it again due to limited time, but as well as the shadows on the moon, being that the light from the sun is meant to be parallel, the shadows are not parallel, they're in different directions, suggesting that they're in a studio of some kind. They get them to fall over on the moon, and if there was really on the moon to 250,000 miles away, then they wouldn't really get them to fall over on the moon, because obviously if they crack the helmet or they rip the suit on a rock or something, they're going to be exposed to the vacuum of space, and therefore it will instantly kill them, basically. So they wouldn't do that. So that just shows that it's all a stunt. In my opinion, that the people kept going up to the astronauts and they kept asking them, can you swear on the Bible that you've been to the moon? And they would not swear no matter what. Now, in my opinion, that is telling, and it is basically damning evidence, because there's only one reason you wouldn't swear on the Bible, and that's if you didn't go to the moon. Because if they didn't believe in the Bible and they were telling the truth, then they would have no problem swearing on it because they don't believe in it, right? And if they did believe in the Bible and they were telling the truth, then again, they'd have no problem swearing on it. If they didn't believe in the Bible and they were lying, then again, they'd have no problem swearing on it. And if they did believe in the Bible, but they was lying, then they would have a problem swearing on it, because obviously they believe in the Bible, they can't swear on the Bible because they're lying. That basically shows that they didn't go to the moon because they couldn't swear on the Bible. And obviously they'd want to shut up all the people who was accusing them and, you know, shut down all the naysayers. But obviously there's only one reason you wouldn't swear on that Bible, and that is if you are lying and you believe in the Bible. Because other than that, if you didn't believe in it, or if you did believe in it and you was telling the truth, then you would swear on it. So that shows us that they do believe in the Bible and that they was lying. And yeah, I think that's basically about it. Yeah, that's it.
Okay, so they didn't swear, so therefore fake. Okay. Toon, I will start the clock for your 5 minutes.
Excellent. I'm going to share a screen here.
Tell me when.
When let's see. Now.
All right, there you go. 5 minutes.
Craig, are you going to get my audio on this if I send the audio?
Yes, I should do, as long as the audio coming through
Okay.
Zoom, I should be able to get it, yeah.
All right. So here, tell me if you hear this.
No, we do not. You're not sending that audio through.
No? Okay. Well, this is, I'll just give a voiceover of it. Here is Eugene Cernan swearing on the Bible. There he is, putting his hand on the Bible. Now, I gave the link to this to our webmaster Ken, the OG Ken, who should be putting it up on the website mctoon.net/sctoon SCT-2. Sorry, it's in the description. So this is Eugene Cernan swearing on the Bible. Now there were 2 other astronauts that also swore on the Bible. So the astronauts did, in fact, swear on the Bible. So that, there, I stopped the share, sorry, without warning you. That is an untrue claim. 3 of them did swear on the Bible. Now, a well-educated Christian who believes in the Bible would know that Matthew 5 says that you should not swear on anything, especially the Bible, and that you should just have your yes be yes and your no be no. So I would not expect somebody that would be a observant Christian to agree to swear on the Bible. They would just say, yes, I went to the moon. So there's that. The moon is self-illuminating. Do you have any peer-reviewed citations for that? I know you maybe want to get them and then we can get them later or something. But do you have any that you can cite?
I have NASA.
That's not much of a citation. So, okay.
I think that would be
so
best.
You don't believe NASA?
For our 10-minute back and forth.
Yeah, that's right. I'm just supposed to. So anyway, if the moon is self-illuminating, then we would expect that there would not be shadows from craters and things like that as the sunlight or the illumination path crosses it. So I would need to have a pretty solid explanation for why that is happening. So something about, I didn't quite get it. The new moon, we should not see it, or we should see it. I'm not sure, but when I'll bring up the globe again here. So if the sun's over here and the moon is here, right? So we have a new moon. So we don't see the moon because it's dark. Well, we can see it still. We always, but the sun hits the earth and the light bounces off the earth and illuminates the moon. It's called earth shine. We do expect a little bit of that when you expose we have a camera and you overexpose the actual moon part of it. The moon blows out and you get a bunch of glare, but then you can see the earth shine. So I don't know why there would be some expectation other than that. It works just fine. The timing, I would love to hear the actual challenges to the timing. I've never heard any challenges to that. And then the shadows. For some reason, the shadows are not as expected. Of course, we have a camera gives you a 2-dimensional picture of a 3-dimensional space. So we don't see and we don't expect to see everything looking parallel if the ground is not all uniform. So if the ground has undulations, then we would expect shadows to come in different directions. And of course, that's perspective. If you look at train tracks, as they go away from you, they're not parallel in your sight. They come towards each other. Everything as they go farther away angles more. So we would expect things to follow the laws of perspective. And this is the most important one. And I've seen this, that there must be multiple light sources is the claim. Well, if there are multiple light sources, then there would be multiple shadows at everything. Everything says, say there's 2 light sources, then a rock would cast 2 shadows, not just one. There you go.
Okay, with 5 seconds to spare. So I guess it's the 10-minute back and forth. Sorry, my phone won't stop making noise.
That's my get up sound. Don't like that.
Yeah, all right. Let me set this for 10 minutes and let's see. 3, 2, 1, and go. 10 minutes.
You want to start, Rachie?
Yeah, I can start. So basically, you're saying that you won't believe that the moon glows in the dark because it's not peer reviewed, but yet it's NASA. Like all of
I just want to see. I just want to see the actual citation and have a chance to look at it and see what they're talking about. See if they're actually saying that the entire moon is self-illuminating, or if they're saying that photons come from it, but it's not significant quantity. That'd be what I'd want to see, because I did see you had a screenshot of something from NASA, but I did you read the whole thing, and does that actually say what you hope that it says?
Well, the citation's in Discord, and basically it says that without any earth shine and without any sunlight, there is like luminescence because of the solar rays. So they give off luminescence even though the sunlight isn't hitting it, and even though the moonlight is the earth shine isn't hitting it. So
okay, did you read the whole thing?
Not all of it.
Okay, does it actually support your position?
I believe so, as it says it glows in the dark, which means that it gives off sunlight, and especially if it's not in the sunlight or the earth shine. So obviously it's sunlight, right?
Yeah. So, well, I'll have a look at it. I suspect, and we'll have this in the we'll link this in the notes here. I suspect it doesn't support what you want it to support, but without reading it, I can't really address it directly.
Okay,
so, all right.
Fair enough.
What about the Eugene Cernan swearing on the Bible?
Honestly, I don't know who that is, but it'd be better if we could see like Buzz Aldrin or Michael Collins or the other one.
Well, there were
Neil
12.
Armstrong.
There's 12 astronauts. 3 of them, there's 12 astronauts that walked on the moon. 3 of them swore in the Bible, and I showed you the video of one of them, Eugene Cernan. So you said none of them swore in the Bible. I showed you a video of one of them swearing on the Bible.
That's fair enough, but some of them would be happy that they don't believe in the Bible, and therefore they'd be happy lying on it. So, but some of them might believe in the Bible, and therefore they're not happy to swear on it, so they wouldn't.
Yeah. So like Buzz and Neil are Christians, and so I would not expect them to. So is Charlie Duke. I wouldn't expect him. I think the majority of them are. So I actually would be surprised to that. I actually was surprised that Eugene did, because I guess I don't know his faith. I haven't seen what he says about it. But if somebody, like I said, Matthew 5 says you're not supposed to swear on anything. So any Christian should say, I don't need to do that. I can just say, yes, I went.
Even if they was in a court of law and they was asked to swear on the Bible?
I guess that's a different thing. But they weren't in a court of law.
True, there wasn't in a court of law, but you say that they're not meant to if they're Christian. So does that mean that if you're in a court of law, you can just say, well, I'm Christian, I'm not going to swear on it?
I don't, and maybe that has been done, but I guess that's not the topic today, though, is it?
No, I'm just wondering why they wouldn't, basically. I mean, I know what you're saying, but then at the same time, I'm thinking, well, what about if they was put in a courtroom, then would they? Because if you wanted to like silence the naysayers and you just basically do it if you was telling the truth and you believed in it kind of thing. So that was just basically how I looked at it, like that basically they wasn't because they believed in it and therefore they didn't go, so therefore like they couldn't swear on it kind of thing. That's how I was interpreting it anyway.
In U.S. courts, you're allowed to affirm rather than swear. Just sorry to jump in.
Yeah, there you go. So anyway, the timing. Is there anything specific you can say about that? Because I don't know. I'm unfamiliar. You just said the timings didn't work.
Yeah, when I was doing this on the video called I forgot what it's called now. A funny thing happened on the way to the moon. There was basically, with the timing that there was meant to be halfway to the moon, they couldn't have been halfway to the moon because of the Earth basically through the window. Like there wasn't enough distance away in order to be halfway to the moon. So therefore the timing wouldn't have been right if that was the case kind of thing. Because obviously the Earth would have been a lot smaller than what it actually was through the window kind of thing.
Did the video include the distance calculations and the angular size prediction?
Not entirely sure, but it did have the timing from when they went, I think from when they left kind of thing, and what the timing was at that precise moment and the day kind of thing. They had the real and the timing and the date, and they was basically saying that the timing didn't match.
Okay, well, it'd be nice if you brought a little of that detail in so that we could examine it right now, but I can't look at it. You just say the timing is wrong and don't give me the analysis. I can't do anything with that. So I would suggest
5 minutes, so.
Yeah, I would suggest that that it on actual analysis that it probably doesn't have any inconsistencies at all. So
well, that's fair enough because you haven't seen it. So
okay, falling over. Can you explain that a little more?
Yeah, if you was 250,000 miles away from the Earth on a moon, which is a vacuum, basically, you wouldn't tell them to fall over on purpose, as they apparently did. They told them to, fall over so that they could experiment, kind of thing. And it's like you wouldn't literally do that because if they crack the helmet or if they ripped their suit on a rock or something, then obviously they're going to be exposed to the vacuum of space and they would pretty much instantly die. So
true. If there was a leak, it would be very bad news. But they ruggedized these things, right? So they planned on having strong suits that could withstand getting beat up. That's definitely was one of the plans. They didn't just get a 50s version of a TV show or movie and put them in some sort of a costume. It was a real suit that they knew with the environment that they were going to, so they were intentionally building it to be able to withstand the rigors of what they're going to be having there. So I don't know why that's a problem.
Well, it's a problem because if there was a tear, and I know you say like obviously that it was probably designed for that like kind of thing, but then like obviously if they're designing it for that, then they're going to have to make it more thick and that like, and it only takes for one thing to be like a rock to be too sharp, or like I said, like for them to accidentally fall on the head and crack the helmet, and they're pretty much instantly dead. So obviously you wouldn't risk that, would you? So
too thick. So they didn't make it thick enough. How thick did they make it, and how thick should it be?
It depends on how sharp the rock's on. Was that on it? Like if this rock's entirely sharp.
But you said it wasn't thick enough. How thick was it, and how thick should it be?
I don't believe I didn't say it wasn't thick enough.
Okay.
Sounds like you wouldn't take the risk, though.
I don't know why that is the necessary conclusion. They intentionally built it to be rugged, and it was rugged.
45.
Okay, so I don't know what. I'm not following. It seems to me a non sequitur that they built it intentionally rugged, and they went to the moon knowing they're going to be on the moon in a rugged space and an area, that was going to be beaten up on it. So I'm not following.
Well, that was basically what I was thinking. Like, it only takes for one sharp thing, or even like the oxygen things that they're meant to wear to, pierce it kind of thing, then they're gone out there. So
1 minute.
Okay. I think we went over everything you said there. I don't. Yeah, the shadows. Do your research. That's there's no problems with the shadows, and the Sirius Moon questioners don't bring that up because it's not really. There aren't two shadows coming from each rock, as there must be if there's multiple light sources.
I wouldn't say there needs to be two shadows if there's multiple light sources. Sometimes I can have multiple light sources in here from my fire and from the light, and there's still only one shadow. So
I see two shadows. I see two shadows on the wall behind you, with that tinsel up in the ceiling there.
That's only one light. That's just my TV light.
No, but I see one from the other direction. From something.
Oh, that's probably my hallway, actually. Yeah.
There you go. I see two shadows. That's the point.
Yeah, but they're from different directions as well.
2, 1, 0. Okay. Right. Stupid phone making noise. Okay. So stop it. All right. And I think we're doing the same thing again, right? 5 minutes, 5 minutes.
Intermission.
Oh yes, intermission. If anybody needs to go to the little boys' room or the little girls' room in this instance, or if I need to bash my phone into the ground because it won't stop making noise. Stop it. You would think that I could just tell it to stop and it would stop. All right. So what do we want to do? How long?
I can show you what I have here. I have the MCToon show glass that I ordered, and I have in it. And here's the tune. It's a little hard to see the tune pimp dog there, and then we've got the cat, the pimp cat here, and it's filled with rich chocolatey Ovaltine.
Yeah, and you might want to shill some of the merch and things like that going on. Because I neglected to.
You did.
You got some merch on.
I'm wearing the 0th episode, which is no longer available. Will never again be available. But in the we do have some new stuff that's available. And Miss Mandy has her own already because she's security. She has a sweatshirt that's hot pink, and on the back it says security. Because she's our chat master for the evening.
Yes, and she is working hard at work behind the scenes, gathering up all of your questions for the Q&A period that I will be reading out here after we get through the next section.
I guess if we had a couple, we could go through a couple now.
Yeah. Do you want to read them, or you want me to read them, or
I can't see them. I don't.
Let's.
You should. Yeah. I can see there, but
let me go over here, and
you have to scroll up to number 1.
Yeah, it's easier said than done. Let's see.
I guess I can see it. I can read it. It says, "Are you saying that the Earth is an equinox? That it is an equinox?" That doesn't make sense. I don't know what that means, so I can't answer that. I'm sure that was directed at me, but it doesn't make sense. So, number 2, the question is for the actual show. Can you put a timer on the screen in the future for the viewers? We are hoping to get that. It takes extra work with the production, a little more, this is our second show, so we're working on some of that stuff. There, do you see them yet, Cliff?
I'm furiously scrolling through pages.
There should be no scrolling. It's go to the live production in Discord.
Oh yeah, it's in the Discord. Sorry.
Yeah,
I'm
it's right at the bottom there.
Terrible at my job. Terrible at my job.
You know what they say, old dog, new tricks.
Production. MCToon. Live production. Chat mods.
Live production, not chat mods.
Live production. Oh, here we go. Okay. Look at me. Look at me finding stuff and things.
Aw. You can learn new tricks.
I know. So question 3, I think, is what we're at.
Super chat from Batman is where we're at.
Yes, a $5 super chat. I am totally not. I am totally not FTFE. So this question is not from FTFE.
It's from Batman.
Yes. I have been to the moon. I've been to the moon.
And Rachie, I have been to the moon. Fought for Doomsday.
Fought. Yeah, I maybe this is some Batman speak that I don't know about.
Fought Doomsday there. It's not. Oh, it's I
don't know what he's saying.
He's saying I'm totally not. Super chat from Bat. I'm gonna have to take over. Oh my gosh.
Yeah.
I'm super chat from Batman. I am totally not FTFE. And Rachie, I have been to the moon. I fought for Doomsday. Fought Doomsday there. So there's another super chat. The moon should be seen during the new moon. Rachie, have you been listening to SE Montreal?
No, no, about that anyway. No,
Have not. But so yeah, the moon should be seen during the new moon.
Should be.
Yeah, you would, if it's self-eliminated, yeah, so you would think so. But all right, question 3. Are we going to go to question 3? Or
yeah, go ahead. Let's see.
Okay. All right. Question for Rachie. Which of the towels in a peer review scientific paper? It keeps scrolling while I'm trying to read. Okay, peer review paper on data samples of the Apollo moon landing have you seen and proved to be fake? So what from the Apollo missions have you seen and proved to be fake?
Petrified wood.
That's I'm going to shut up because I'm not a debater.
That's not from the scientific papers on data samples from the Apollo moon landings. And my goodness, and the petrified wood, you should definitely do a little research first. That was never claimed to be from NASA. That was a oh my goodness.
Yeah. I'm not going to say anything as a debater, but I do owe a public apology to my friend FTFE for because I used to yell at him when he would butt in during my debates. It's so hard not to. So I apologize, FTFE. I'm still not going to.
The petrified wood?
All right, I'll tell you about the petrified wood. I think I minimized it already. So the petrified wood thing is not actually real. It's not a thing. So it was a tour in 1969 when some of the astronauts came. They did a tour around the world. And they came to the Netherlands, and the former prime minister who had been out of office for 10 years was the one who later showed up with this claimed petrified wood. Now, NASA was not giving out samples at the time. They typically gave it to current heads of state, not former heads of state. And they did not give it out from the astronauts. It was the State Department, the US State Department, that gave it out. None of it matches. And in fact, in the actual, the display doesn't even say it's from the moon. It just says, with the compliments, the ambassador of the United States of America, J. William Mittendorf II, to commemorate the visit to the Netherlands of the Apollo 11 astronauts, and then their names, and then October 9, 1969. That's the actual plaque. It doesn't say this is a moon rock. It just says with the compliments to commemorate the visit. And then the rock is somehow in that collection. How did that rock get associated with thinking it was moon rock? It is unknown, but but there is no actual claim that that rock is from NASA. Now you can order samples. They send out about 400 samples a year, and you need to return them from the actual. Who is it? It's the curator.jsc.nasa.gov/lunar. And I'll put that for our webmaster to include. So if you want to actually sample the rocks, get a geologist and look at them to see if they look like they're from an Earth source or a non-Earth source. You can do that. But the petrified rock in the Netherlands never was actually claimed to be from NASA.
Okay. And we have a $5. Go ahead. Have your chance for rebuttal.
No, I was just going to say I heard different, but I'd never heard what MCToon had said before. Like, I've never heard that story before, so.
Okay. So there's a $5 super chat from Eddie Reese. It said, you asked and you were shown a video of an astronaut swearing on the Bible, and you are still not satisfied. Don't you think that's moving the goalpost? ?
Well, no, because there was 4 different reasons. Like, so there was, if they didn't believe in the Bible and they were telling a lie, then they would do it, which obviously some of them have done it. If they didn't believe in the Bible and they were telling the truth, then again, they'd do it. You know what I mean? Like, there's different reasons they'd do it. They don't necessarily have to be telling the truth in order to swear on it. They might not even believe in the Bible, kind of thing.
So then how would that be proof of anything if they didn't swear on the Bible?
Because obviously if they didn't swear on the Bible and they did believe in the Bible, then obviously that shows you that they didn't go to the moon. But obviously if they didn't believe in the Bible and there was lying, then obviously they'd do it anyway, like the 3 that you've mentioned. So obviously they probably don't believe in the Bible and were lying anyway. So.
And of course, none of it actually is evidence for or against going to the moon.
Right.
That's the most important part of this. It is actually completely not evidence at all, no matter what they do.
Okay. Question number 4 for Rachie. What is halfway to the moon? No, this is just mean. Okay, but I'll ask it anyway because it was a question. What is halfway to the moon in metric units?
Halfway to the moon in metric units, 125,000.
Okay. Question number 5. Question for MCToon. Did you literally think the Earth is
round?
Why was it did? Why was it don't? Okay. Did you literally think the Earth is round, and do you think it's more spherical shape?
Yes.
That's horrible grammar. Sorry.
So sometimes people say round when they mean spherical. Don't hang on the particular words. Do try to understand through the context. So yes, the Earth is a sphere. It is an oblate sphere. It is a very slightly smaller radius from the center of the Earth to the poles than it is from the center of the Earth to the equator.
Right. Okay.
So we probably could move to the next.
Yeah, we probably could. We've got a few more, but we can save them for the next section. I think, what do we got? Another 2 5-minute sections for each of you?
Yes.
I believe. And so I guess, Toon, you're going to start since you started the first one, or are we going to swap it up?
Yeah.
Okay.
I'm ready.
Let me get the timer.
I'm going to share screen, Craig.
And tell me when.
when. So
There you go.
I took I like doing it this time of year because the first time I measured the radius of the Earth myself was 2 years ago on the December solstice in 2019. And here are some pictures I took on that day. There is my setup, a tripod there. I measured the length of the shadow and the height of the tripod. I use that to get the angle to the sun at local solar noon. 22.54 degrees is the angle. So that went in. There were two others of us that did it the same day, at the same time. Not same time, different solar noon for everybody. I got an elevation of the sun of 3,162 miles. Now, somebody else on the same day got an elevation, assuming flat Earth. Sorry, this is very important. This is not assuming that the Earth is a sphere. This is assuming that the Earth is flat. 3,047 they got. And somebody else got 4,468. Strange, they all get different answers, but let's just go with mine, 3,100. It's commonly said, and this goes back to Samuel Rowbotham, that the sun is about 3,000 miles in elevation. Measuring it on the right days at mid latitudes gives you about 3,000, assuming the Earth is flat. So what I did is I just did a little bit of triangulation. So let's take it at 3,000 miles, right? And on that day there, the thing is that 12 hours after local solar noon, the sun is over a different part of the Earth. You can see right here. Here is I'll do Minneapolis. Here it is, because I'm in Minneapolis area. There it is. So there is Minneapolis right there. You see on the left side, and at local solar nadir, which would be 12 hours after local solar noon, the sun is over the this is sorry, this is a different time of year, but it doesn't really matter much, I gotta tell you. It would be directly over Myanmar on the Tropic of Cancer. So this is for the June solstice. And taking the 3,000 miles, then we can do the math, and we can say that on that day, in the middle of the night, the sun must be 21.35 degrees in elevation. In the middle of the night, just doing basic trigonometry, solving a triangle, something that we teach right here. We teach to kids about in 8th grade is when they learn to solve a triangle. So this is 8th grade math skill here. In the middle of the night, if the Earth is flat, now this is assuming an AE map. Don't know what your map is, but the important thing is it doesn't matter what the map is, because no matter how far away it is, we can do the triangulation. And the angle will always be positive. Never, never, never will it be negative. Never will the sun, by triangulation, appear below the horizon. Even worse, we can try to force it. We can go with some crazy numbers. Lower the sun to 1,000 miles, still 3.2 degrees above in angular elevation. What if it's 1,000 miles high and 30,000 miles away? Well, it's still 1.91 degrees in angular elevation, still above the horizon, right? The angular size of the moon is 1/2 a degree. So it would be almost twice, almost 4 times the width of the moon above the horizon. Now, if there's mountains or things in the way, that would be a problem, but people live near the shore. They live near oceans. So if we move the sun to 3,000 mile elevation, 8.5 million miles away, it would be within small enough for the human eye to not distinguish that gap. But that's how far it'd have to be, 85 million miles away. So that doesn't work very well. Here is, just for an example, this is what it looks like for something to be 9.53 degrees above the horizon. Now, as I said, in Minneapolis, It'd have to be 21.35 degrees, significantly higher than that above the horizon. Yet we never see that. We see the sun set. And when it sets at full size. All right.
So Rachie, your rebuttal. Let me know when you're ready.
Okay, I'm ready.
All right, start.
Okay, so basically you're using trigonometry for something that you can't really use trigonometry for, because obviously you're going to have optical effects and things at play, which is going to obviously change the angle of things and where you see them. And obviously I don't think the sun is 3,000 miles high. To me, it would probably be something like 200 miles high in order to be able, like you say, if you was to use the trigonometry in order to do it, then obviously it would have to be like less than 3,000 miles high, but that's excluding any other factors. So obviously, if you do it on pen and paper, sure, or on a simulation program, sure, then you're going to get that kind of answer, but you're not including the atmosphere and all the other effects that come into play. So no, I don't believe that like you can just do it with triangles to triangulate the distance to the sun. But I believe it's like a lot less than 3,000 miles. It's probably something like 200, 250, probably even less than that. And that's basically it.
That's it?
Yep. That's all he's saying, is that basically the triangles would have to say that the elevation would be 3,000 miles, but he's not taking into consideration any other effects. All he's doing is the geometry without any effects taken into account, which obviously those factors play a role. So
okay. So that was 1.5 minutes. What do we got next? Another 10 minutes.
10 minutes,
yeah, another 10-minute open discussion. So let me reset. Sorry about that. And 3, 2, 1, and go.
All right. What's your 200 miles based on?
well, based on doing the trigonometry like you have, I've done the trigonometry and I know how much it doesn't.
You just said I can't use trigonometry.
No, but I haven't finished. I've done the trigonometry like you did, and I noticed that it wouldn't set. But obviously, with how high it would be above the horizon, you've got to then take into consideration all the effects. And we know things disappear bottom up. And obviously that would happen to the sun with distance as well. So therefore, when the sun travels away with distance, it's going to start to appear lower and lower in the sky. So therefore, you will get that lower angle than if you was just using trigonometry alone, because you're not taking into consideration any factors whatsoever of the atmosphere or any other optical effects that might come into play with it. All you're doing is basically
so
a triangle.
Like what does the atmosphere do to distant objects?
It makes them appear to disappear bottom up.
And the peer-reviewed citation for that?
Well, it's what you would call refraction, but you think it works the other way. I mean, it can work both ways, but most of the time it works the other way. So that things disappear bottom up kind of thing. And
but how does, where's the peer-reviewed citation that shows that the sun, that refraction should cause things to disappear bottom up? I've never seen that.
Okay, well, peer review, I wouldn't really agree with, because that's kind of consensus, isn't it? It's like me saying to you.
Oh, it's peer review is the opposite of consensus.
I wouldn't really say it is, because it's like me asking you to peer review something of mine. You're peer reviewing it. You agree with me, therefore you agree with me. It's consensus.
Oh, that's not how peer review works. Not at all. That when something's peer reviewed, the reviewer wants to shoot it down. It's something that they desire to do. And once something's published, even more, the people that are the other people in that particular field, if they think it's wrong, they definitely want to shoot it down, because then they get all the street cred from the people that they shot down. So peer review isn't consensus. It's the opposite of consensus. It is a vulture's feast if you get it wrong. So but here's what refraction actually is known to do. It's known to cause things to appear slightly higher, not much at elevation, but slightly higher. There's tables in the nautical almanacs that tell you how much higher something at elevation should be. And at 15 degrees angular elevation, it'll add add, not reduce, add doesn't help the sun to appear to set, add a couple arc minutes at most. So if you do take refraction into account, it doesn't help you because it will make the sun appear slightly higher, not lower.
That's what you say, but I've done refraction tests myself, and it's made things appear lower. So by making the medium denser, it's made them appear lower, not higher.
But making the medium, what medium?
Like I've had a bottle kind of thing, and I've tried it empty at first, and then I tried adding water, then I've tried it with salt water where the salt's on the bottom, and then shook it up, and then so it's basically homogeneous kind of thing. And I've put objects behind it, and every time it's made it appear lower. Every time I've made it denser and denser, it's always appeared lower, never higher. And obviously the medium is denser.
I would love to
refraction.
see what you're talking about, but I have a list of citations of peer-reviewed papers on what refraction does on my website at mctoon.net/refraction, a long list of papers there. And the index of refraction gradient in our atmosphere is lower. At low elevation, the index of refraction is higher than, and it reduces as you go up. This causes things to bend down, which doesn't seem natural until you think about it, makes things appear higher because the angle of incidence as it comes into your eye comes from a higher angle. So unless refraction, for some reason, the index of refraction gradient is reversed, which is extremely rare, but possible, but it creates an unstable condition because you need to have cold air above warm air, which will go chaotic quickly.
Well, I have videos that I've done on my channel that show me using a denser medium and me keep changing it kind of thing, and it shows it lower. So
okay, so
obviously,
I'm gonna
opposite.
Yeah, I'm gonna go with the peer-reviewed papers and the people that actually had well-controlled experiments over that.
Have you done it yourself?
I'm gonna go with the peer-reviewed papers.
But have you verified it yourself?
Science doesn't require me to verify things myself.
I agree, but like you just believe in something, then aren't you? You haven't even tried it. Or...
No, not at all. There's a large list of peer-reviewed papers that have experimented with this and measured it and confirmed it. And like I said, in science, if you can ruin somebody's day by showing that their paper is wrong, you get all their street credits, greatly to their benefit to do that. But instead, you have paper after paper, experiment after experiment, measurement after measurement, confirming the same thing, that the coefficient of refraction causes things to appear higher.
So could you explain why I got a different result when I actually experimented with it?
Probably because you didn't do the experiment very well. But it doesn't matter. But it doesn't matter because like I said, the sun with zero refraction would appear 21 degrees in angular elevation. Can refraction cause things to appear 21 degrees? Now, this is middle of the night. It has to do it much more than that earlier in the day. Cause things to appear that significantly different. And you'd have a very high bar to suggest that because of the contradictory evidence from all of the many years of peer review papers and measurements.
21 degrees based on what elevation?
I did the math, right? So, yeah, I used 3,000 miles because I measured the sun to be 3,000 miles.
So if you use 200 miles, then what would you get?
Still above the horizon. But you need to, well, refraction would cause it to be slightly higher.
Working the other way.
How much? So you can't even quantify that. You don't even have numbers. You're just like, oh, it made it look that way. But like I said, I'm going to question whether or not you controlled for conflated variables, or if you put the observer in the right spot, if you quantified the refraction. I mean, what did you do to do this? The experiments that are the measurements I'm talking about, they use two theodolites, and they measured reciprocal zenith angles and did it over the course of many hours using automated systems to measure the angles to better than around 1 arc second. So I'm going with that.
Not really as accurate as what I did when it's a lot closer.
Way more accurate. Way more accurate than you did. Do you know how big 1 arc second is?
Like very small.
Very small, yes. There are 60 arc minutes in a degree, and there are 60 arc seconds in a arc minute. So it's 1/3600th of a degree. So that's the accuracy of a high quality theodolite.
That's what they tell you the accuracy is.
Yeah, that's the oh my gosh. No, that is the absolute necessary. If it's just what they tell you, then the people doing all of the work using theodolites would have severe problems with their work because stuff would be off.
That's why they think it's curved, because it's not.
Well, then show the actual errors. Don't just say it, you got to show it.
I would if I could build a straight line long enough, but I can't.
There's other ways to do it, Rachie. There's other ways to verify the accuracy of a theodolite than to build a physical straight line for some long distance. They actually have ways to do it. These people that do this for their career all day long, this is what they do. For centuries, these people have been doing it. They know how to make an accurate measurement using a theodolite.
I disagree, because obviously you end up with drop, and I don't think it really is a straight line. If, like I said, if you were to build a straight line and then use it, so you had a light along it, even if you did it with LIGO or something, and you put the theodolite at the beginning and then looked along it, I reckon you'd still see that the LIGO wouldn't be straight according to the theodolite, in my opinion.
40 seconds.
All right. So it's her opinion. That's all right. I'm done.
Okay. I know what I'm going to do next time I go to buy a car and they say it gets 30 miles to gallon. I'm like, that's what they want you to think. So, anyway, I just dropped my phone. What's our next? We are into the
Rachie's.
It's her turn to do stuff and things, mostly things. So, Rachie, let me know when you want me to reset the if my phone will shut up. Tell me when to click start.
Okay, start.
There we go.
Okay, my second claim is that they don't know what gravity is, and that Einstein does not reduce to Newton. And there's a clip from Brian Keating, I believe his name is, and he's basically playing a video with this person, and this person basically tells you that physicists will actually tell you that they don't know what gravity is, and that there's a disconnect between normal people like us and physicists, and we pretend we know what gravity is. Like, for example, we'll say, what do you mean? We do know what gravity is. If we drop the apple, it falls, that's gravity. But physicists will actually tell you that no, they don't have a clue what gravity is. And he's actually a physicist himself and wrote a book on it and that. And then you've obviously they think they know what gravity is, as in normal people, but there's actually different theories. If you look on Wiki, I sent a screenshot to the Discord. There's loads of different types of gravity, and you wouldn't need all these different types of gravity if you actually knew what gravity was. They say that Einstein reduces to Newton. Again, I sent a screenshot of this. That cannot be true. After all more research I have done, they say Newton is the inverse square of the distance between the masses and the center of them. But that can't be true, because Newton actually wrote in his article it was Prop 37, that it was the inverse cube of the distance that worked on the type to create the type. So that's not the inverse square if they're using the inverse cube, and the links have been sent both in Discord. He didn't know the mass of the moon. He overestimated it by 100%. That's a lot to overestimate it, especially when you're talking about gravity and the accuracy of it. Yeah, he says that the other side, so the one side was closer to the moon. So obviously, again, it's not from the center of the mass. So if you had the mass of the Earth, and then you had the water here and the water underneath it, and the moon was up here, then this bit of water is closer. So it's basically trying to pull on it harder. So it's not from the center. and the bottom would cause a tide because of the centrifugal force. It's ridiculous, in my opinion. There's a lecture that I sent from Richard Feynman to the Discord as well, which basically tells you what I've just said, that it's pulling on the mass of the water instead of the mass of the earth as a whole. So it's not pulling from the center of the mass, it's pulling the water closest to it. And then this bit gets pulled off by centrifugal force, which again is ridiculous when it's meant to be the center of the mass. And now obviously space-time. So kind of doesn't fit. They tell you that it reduces to newtons, but it doesn't. There's a document that says that in one document, it says that linearized gravity predicts that the motion of masses produces magnetic gravitational effects very similar to those of electromagnetism. On one final note, somewhat troublesome point, it says that it deserves further comment. Above, we showed that general relativity reduces to Newtonian gravity in an appropriate limit, but strictly speaking, we went beyond the linear approximation to show this. If one stays consistently within the linear approximation, one predicts that the test particles and the test bodies are unaffected by gravity. Einstein himself apparently said, since the mathematics have invaded the theory of relativity, I do not understand it myself. That's what Einstein said himself, that he did not understand the theory of relativity himself since the mathematics got involved. And then later on, when he came up with his general theory of relativity, it says that he had to acknowledge the indispensability of the four-dimensional scheme of the Minkowski space, which is not 3D plus time. It's actually 4D, which obviously we know, most of us know 4D is 3D plus time. That is actually not what the Minkowski space is. It's just the 4D. It's not. It doesn't have a time dimension. So that proves that Einstein does not reduce to Newton, and that he's not even using 3D plus the 1D of time as you claim that he does, because the Minkowski space is not 3D plus the 1D of time. It's just 4D on its own. It doesn't even have the time dimension separately. Well, it doesn't have the time dimension like how you like describe it with the 3 dimensions of space and the 1 dimension of time in the manifold, which basically creates this space-time that mass warps. So it's a different kind of 4D than what you actually think it is. And it says
that's time.
All right, I'm ready.
Yeah, 10 minutes.
All right, I'm going to share.
Hold on, let me just reset. And go.
All right. Well, that was a lot, and I disagree. QED. I'm kidding. That's basically what you did with the last one. So I have stuff here. First of all, Einstein did not disagree with Newton. Here is a quote from him. No one must think that Newton's great creation can be overthrown in any real sense by this or any other theory. His clear and wide ideas will forever retain their significance as the foundation on which our modern conceptions of physics have been built. And there is the citation there for when he said that. You did reference Feynman. Feynman definitely does not disagree with Einstein about gravity and mass attracting mass. And the most important thing is, none of what you said actually addresses the problem for flat Earth, which is that mass does attract mass. So if there's 100 other theories about how gravity works, all of them include mass attracting mass, and don't help the flat Earth at all, because a flat Earth would collapse as long as it's over the potato radius, which is about 200 to 300 kilometers, which the Earth certainly is. So none of it, at best, even if you're right on everything, none of it actually refutes mass attracting mass. But and I don't know where you got that Einstein's field equations do not reduce to general or to the Newtonian limit. They do, in fact. So I have right here, mctoon.net/Einstein, 4 different citations. The first 3 are Einstein's field equations reducing the Newtonian limit, and the 4th one is the Newtonian limit expanding to Einstein's field equation. I'll show you them. Here is page 71 of the first one there. Which is 76. The first one is called General Relativity by Robert M. Wald. Right here, the Newtonian limit. Thus, the first crucial set of general relativity is that its predictions reduced to those of Newtonian gravity under the circumstances when Newtonian theory is known to be valid. Specifically, when gravity is weak, the relative motion of the sources is much slower than the speed of light, and the material stresses are much smaller than the mass energy density in units where C equals 1. That's where speed of light is unity, right? I think. So here is the actual derivation of it. It winds up with down here in the, I'm not going to go over the math. I can follow along. I cannot derive it myself. But there's the first one. Second one here, we have the field equation. It turns out that this prescription can be chosen so as to reproduce the results of Newtonian gravitation theory in the limit of small, slowly varying curvature. Again, that's the same conditions in our reference frame as how people often say it. Here is the third one, the Newtonian limit. And again, it derives the Newtonian limit from Einstein field equation. I'll jump over the problems there here. He goes over it, right? Anyone who's like, hey, it doesn't reduce to Newtonian, go ahead. Show where this is wrong. And then here's the fourth one. This is from Sean M. Carroll, Space-Time and Geometry, an Introduction to General Relativity. This one is actually starting with the Newtonian limit. That's what this is a Newtonian gravity in expressed differently. And he moves up into the Einstein field equations, ending with, down here a little farther, the Einstein field equations come right there. You go right there, 4.44. That is Einstein's field equation right there. So it does in fact, and there's your citations. Again, MCToon.net/Einstein if anybody wants to do that. Now it has been empirically confirmed. You don't just hand wave things that have been empirically confirmed. For example, Haefel-Keating, they took 2 clocks, cesium clocks. They flew them in opposite directions around the Earth, and they left at different times, and they left a pair of clocks stationary. Total of 4 clocks, 2 moving, 2 stationary. They compared the time before and after. The times that they went one way, the times they went the other way. Gained time and lost time. They were extremely accurate, and the prediction matched the observation. Einstein relativity confirmed. Another one, the very first one, was Eddington 1919, when they saw the light of stars bending around the sun due to its gravity. But none of that really. We don't even need to go that. We can just measure to see if mass attracts mass. And there are many experiments and measurements of that. I have them on my website, mctoon.net/G. You can see, I think I have 18 of them here, including my favorite one, which is they used not a torsion balance, but they used liquid mercury. They used several tons, not mercury. Yes, mercury. They used several tons of liquid mercury and moved them around above and below these balances to see what happened. And it worked. Gravity confirmed. But here's the most important one for flat earthers. I have a $10,000 flat earth gravity challenge. If you think gravity is not real and it's not mass attracting to mass, I challenge you. It is free to enter. $10,000 can be yours if you beat gravity at its own game. All you need to do is be better than gravity at predicting the specific value of gravity at different locations on the earth. You can find that on my website, mctoon.net. And that is a refutation of gravity. Your claims about gravity. I'm about to stop the share. Here we go. All right. How'd I do on 5 minutes? Close. You're muted there, Cliff. You're still muted.
Sorry, I clicked the wrong thing. There's 3 minutes and 20 seconds left for rebuttals.
I went quick. All right, we can go to our 10 minutes.
Yeah, no, I'm happy to go longer. That's what she said.
All right. Let's switch to our 10-minute back and forth then. We good?
Yeah, no, I'm ready when you are.
Okay. Go ahead, Rachie.
Okay, so where I got my information from was actually from your website, from your citations.
Okay.
Okay, so it says in your citations that, strictly speaking, we went beyond the linear approximation to show this, that it reduced to newtons. We went beyond the linear approximation. And it also says that if stays...
What is the linear approximation?
Well, the linear approximation will be newtons because it's not the bendy spacetime.
Are you sure about that?
Pretty sure.
Are you sure about that?
I'm pretty sure, unless you want to tell me I'm wrong somehow.
No, it's not. It's not right. But go ahead.
Okay.
Yeah, I guess if you had a different linear approximation.
So you're saying Newton's not linear?
I'm saying that when you the linear approximation, that those two words together, is not talking about the Newtonian limit.
But they're talking about reducing from Einstein to Newton. So
that's a
why wouldn't
different
you be
thing.
talking about Newton?
That's a different thing. Yeah.
Care to elaborate?
No, it's your claim.
Yeah, because in your citations, it tells you that it goes from Einstein to Newton, and that they have to go beyond the linear approximation. Linear meaning Einstein, Newton, because Newton's is linear. You're saying no, but you're not giving me a reason why.
That's not what it's talking about.
Then what does it mean then?
I don't know specifically what you're talking about. But it's not the linear approximation is not Newtonian gravity.
So how can you say that's not what I'm talking about if you don't know and you don't have an answer for what it actually is?
Yeah. Sorry, I don't think you quite understood what it was talking about.
This is what I'm asking you. So can you tell me what that means then?
Why do you think that Newtonian is linear?
Well, because it's not bendy spacetime. It's like straight. It's not curved like bendy spacetime.
No, that's it. Linear would be speaking about a mathematical concept.
Mm-hmm. So Newton's is mathematical, though.
No, I don't. You don't. It's an algebra thing. How much algebra have you had?
Since when I was in school.
And how that doesn't tell me. I don't know how far what you did in school. Did you take, for example, did you take engineering classes and go through calculus and things in university?
No, only high school.
Okay, so you didn't do a whole lot of algebra.
We did algebra.
Yeah, did you do linear algebra? Did you do differential equations? Did you do matrices? Did you do calculus?
No, but how is any of this telling me what linear is?
Yeah, all right. The linear approximation is not referring to Newtonian gravity, and there's nothing about the Newtonian equation that's linear. So it's just not what it's talking about. You didn't understand what you were reading.
Okay, so explain me.
It's your claim. I'm not going to derive the Newtonian limit right now. We don't have time. It would take significantly longer, and you do not have the prerequisites to understand it.
Well, you're saying that, but how can you say I don't understand something without explaining it first? If you explained it and then I didn't understand it, fair enough, but you're not even explaining
it. It would just be mean at this point.
Yeah. All right. I'm not.
Rachie,
honestly, I don't. All right. Rachie, I don't want to be mean to you. This is not. It is not what you think it is, and we can't go over it right now. If you want, I can send you some resources to have a better understanding of how that stuff is done, but it's not actually what you think it is. And so I don't want to be mean.
Okay. I'm just saying it's from where it's meant to be in your sources to reduce from Einsteinian to Newton. So that's what I'm taking it as. And then it also goes on to say in the sources that you put up there that basically one predicts, so if we stay consistently within the linear approximation, which apparently isn't what I think it is, then one predicts that the test bodies are unaffected by gravity. But you're saying that the linear is not referring to Newton, even though it's Einstein reducing to Newton and it's actually something else, but you can't tell me what that something else is. But so yeah, I guess I can't really say anything because I don't know what that something else is, do I?
Yeah.
So I guess we're stuck on that because I thought it was Einstein reducing to Newton and Newton was linear, and therefore it was about Einstein reducing to Newton because that's what it was. And you're saying, no, that's not what it is. So I'm at a loss, shall we say.
Yeah. So to be clear, you can't refute the math if you don't have the math. And I got to be honest, I don't have the depth of math that I could begin to attempt to refute any of the things in the Einstein field equations. I couldn't begin to think about that. That would be extreme hubris for me to think that I could do that. I don't have the background of that. And I studied electrical engineering. I took engineering math. I took calculus. I took matrices. I took differential equations. I could not do it.
Okay, I guess I just need to find out what that means by linear then and reduce it from Einsteinian to Newtonian before I can even say anything else then.
So I'd suggest probably what you want to do is you want to enroll in a year of calculus and then get onto things like matrices, differential equations, linear algebra, then see where it goes after that.
Okay. Well, I guess that's all I got because obviously I thought it was Einstein reduced to Newton and linear, so I haven't really got anything else if that's not what it actually is saying when it's meant to be the part where it reduces from Einstein to Newton, and you're saying it's not meaning that. So
yeah, and like I said, I'm not trying to be mean. It is.
No, I don't think you're being mean.
It's beyond. Just seriously, the Einstein stuff pushes my limits, and I haven't done this math for. I write software. I don't deal with complex math like I did when I was at university. It's out there. And so, yeah. All right.
Yeah, I guess that's it. That's all I got.
And the thing is, I've not met. There's a couple flat earthers that I know that have some college level, some university level math. Just a couple, and that is absolutely the bare minimum. Is a lot of math in order to try to address that. And I mean, it's not you. It's none. So. Right.
Okay. So there's 2.5 minutes left. I guess we'll just abandon that. And I'll say, I took, I have a bachelor's degree in electrical engineering. I did Calc 1 and 2. And I'll agree with MCToon. At some point, you learn all this math and 2 years out of it, you've forgotten most of it. So, the math is complicated, but enough to know when you look at something to know that that's not right. Yeah. So I think that's where he and I both are at this point. So I think we're at Q&A. Is where we are right now. Let me pull up the chart. Let's see. We got basically Q&A for as long as it takes is what it looks like to me.
Yeah.
So I'm going to go to Discord and hopefully Miss Mandy has
she is on top of it tonight.
Yeah, it looks like
and so is Ken. If you look at the website, Ken, the OG webmaster, on the website mctoon.net/sc-2, he has all of the citations up so far. So he is on top of it. If anybody's ever wondering what I was talking about, it's there. And same with Rachie's. All of Rachie's citations are there too.
Okay. I think we went through, like, what was it, 1 through 5. So we should be at number 6 right now.
Yes.
I think we went through 1 through 5. Okay. Question for Rachie. Can you describe a sunset on a flat Earth? Does the sun get below the observer's feet? Yes or no?
Not physically, no. So no.
Oh, sorry. I guess that's the end of y'all's last.
Y'all.
I'm from the South. I'm going to say y'all, and you can just be mad at me.
Oh, I'm not mad. I'm amused.
Amused. I'm happy to amuse Northerners as you are up there freezing. It was 70 today.
Oh yeah, don't bring that up.
Yeah.
You win.
Question number 7 for Rachie. Hopefully we got some for Toon. It looks like a lot of them are for Rachie, but can you hold on? No, that's one I already read. All right. Question for Rachie. If NASA faked the moon landing, why are people all over the world able to track spacecraft both
Optically?
optically and by radio?
If sorry, can you say that again?
Okay, so if they faked the moon landing, then why were people able to shortwave radio people? They were able to track it via radio waves.
Okay, I'm not sure if there was or not. Do they have any evidence of that? Because if they don't, then it's kind of a claim without evidence, right?
There was tons of people that tracked it.
You need the evidence. Claim without evidence can be dismissed without evidence, right?
There are audio recordings from third parties of the Apollo missions
All over the world, from other countries, people that hated us.
Yeah, well, they pretend they hate each other, but really they're working together.
Okay. All right. Let me pre-read this. I just want to make sure it's not something that's I'm going to be reading something that's hateful.
No, it's okay. I'm used to it.
Okay. Can you explain how I told God damn it, people. Use better grammar. Can you explain how I told I would work? Oh, it would work on a flat Earth.
Just plow through it.
I'm trying.
Here, I'll show you how to do it. You go, can you explain how I told it would work on the flat Earth without the proper use of gravitational pull?
I don't understand the question.
I think there's how
I was trying to make it grammatically correct to where she could understand it.
Yep. How would it work on flat Earth? How would things?
How would what work on flat Earth?
Yeah, without the use of gravitational pull.
Gravitational pull. We got to give her a pass on that one because I don't even know what that means.
No, man.
Yeah.
Okay,
right.
Number 9. There are 144 peer-reviewed scientific papers in the January 30th 1970 issue of Apollo 11 landing, have you proved them fake?
No, I have not. I haven't even looked at them.
Okay. God, they're all for Rachie. Like, can somebody like put one
Do
in
you
there
want
for
a
Toon?
MCToon?
Like,
I think Batman has some pokes at me.
okay. Right. Number 10 for Rachie. Do you have any literature that you can bring to the camera to literature? Do you have any literature you can bring to the camera to show us?
Not at a specific moment in time now. I got quantum mechanics book, but I'm not sure where I've put it.
For Rachie again, how far away is the moon? Not that's a pretty good question.
In my
Because some
opinion,
believe. Well, let me just finish the qualification, because some believe it's 293,000 miles away. So how far do you believe it is?
I haven't really thought about it, but I'd say it'd have to be less than the sun. So if we say the sun is about 200 to 250 miles, then I'd say the moon is probably like 100 to 150 miles up. Because obviously it's got to be lower than the sun because it gets in front of the sun, right? So.
Forgive me, but how did you arrive at those numbers? I'm not going to go beyond that, but just.
Well, doing some of the trigonometry and then trying to figure out how it would be with just trigonometry without other effects. So basically from trigonometry.
You arrived at that via trigonometry.
Pretty much for how much it would have to be towards the horizon kind of thing for the sun originally. And then obviously the moon would have to be lower. So.
Okay. Next question. Can you give me your proper definition of evidence?
Evidence, basically scientific method is evidence. So if you have an independent variable, dependent variable, you wiggle the independent variable, you see whether it causes a change in the dependent variable, and then you know whether you've got the cause and effect relationship, and that is the evidence.
Do you have, out of curiosity, do you have a comprehensive reference for the scientific method that we can look at?
What's that, sorry?
You have a reference, a comprehensive reference that goes over the complete, the way to do science. You know, like one reference that we could just look at and that you refer to primarily.
I could send you a link later on, but it's basically like observation, hypothesis, independent variable, obviously control your variable.
Yeah,
and then your dependent variable.
So where is this link to? What is the source, the citation to?
Well,
like,
there's many.
Is it? You said you can give me a link, say singular link. So this singular link, where is this this reference that you're?
I can give you many links which basically say the same thing. Many links that would say the same thing that the scientific method is.
So if the first one, if you just were to pick the one that if you're like, if I just like, or somebody asked you, I just want one link that I can look at that tells me where to go for science, where would that be?
I'm not sure the exact website's name, but basically if you just type in scientific method in Google, it should pretty much come up and tell you exactly how to do it. Okay,
well, I can answer the question for myself. I would send people first to Berkeley's website called Understanding Science. And that's a fantastic reference written to about a first year college level or university level person reading level. So that's where I have
an IV and a DV.
Nope, they are not actually required in an experiment.
I didn't think it would.
No, of course not. It's not. That is not actually a mandatory part of it.
I disagree. It's a cause and effect of the relationship. You need to know the cause of the effect.
But you disagree with Berkeley and Stanford and Richard Feynman and Karl Popper. So that's why I'm asking for a citation, because you're not the expert on science, Rachie. You're not the one that people come to say, how do we do science? You don't even have, and neither do I, any peer-reviewed papers that you've engaged into the scientific discourse. So that's where the two of us, neither of us are experts on that. We can't cite ourselves. We would need to cite a third party.
So how would you determine cause and effect without an IV and a DV?
That's not part of an experiment. That's necessary.
So you don't need to know the cause to the effect.
Exactly.
Really?
That's not how that. What did Richard Feynman say when in the citation that you provided? What did he say for how to do an experiment? He said, first you take a guess, and the audience laughs, and he says, no, really, that's what you do. You guess. That's the hypothesis. You guess. Then he said, you compute the consequences of that guess. That's the prediction. Then you check to see if the consequences that you computed match observation. That's it. That's his quick overview. Where did he say there's a necessary IVDV? He did not say that.
I don't think he was talking about the scientific method, though, was he?
He absolutely was. That was the
point
of his lecture. That was the absolute point of his lecture.
No, it was about the law of gravitation. No, it wasn't the scientific method or anything.
Watch it again.
I will.
All right. You can move.
Yep. I'm trying to click back over to the. Why are there so many tabs open?
You have that many tabs open? I love tabs.
I've got a lot of tabs. I'm almost like your former buddy. Give me just a minute to keep clicking and damn it.
You want me to read them?
Yeah, I guess I know what the next one was. It was go ahead. Sorry.
All right.
Your next question.
Asher, a super chat from Asher 1776. Dash. I don't know. Dash. I give her credit for doing her own experiments. However, I think that's Rachie. Maybe that's his name. Anyway, I give her credit for doing her own experiments. However, if we can't trust science, how do we know the temperature of the sun except hot?
I don't think they do know the temperature of the sun. I mean, they sent a probe recently, which apparently touched the sun. I mean, what they come up with is ridiculous, to be honest. But I mean, nothing would it be able to withstand, what is it, 5,000 Kelvin or something like that? I don't think it'll be able to, even nothing, any material that we can create anyway, I don't think would be able to even get to the sun, even if you could get to the sun, which obviously is begging the question of space and things. But yeah, no, I don't think really just because somebody says it's a certain temperature and everybody agrees that necessarily means that's true.
Okay. You ready, Cliff?
Okay. Yeah. I think I found back where we were, the temperature of the sun. So, but like seriously, if you don't know how hot if you don't know how hot the sun is, then how can you make predictions? Never mind. I'm not a part of this debate.
To be clear, the Parker Solar Probe didn't touch the sun. That's a headline.
No.
And if you look it up, you can see the actual temperatures, and it talks about the particular materials that they use that are able to withstand those temperatures. Not a problem. It entered, I think, into its outer something. It was still millions of miles away from the real hot part. So.
Okay. But I still don't think they know the temperature, to be honest. And obviously all that's fake. So.
Okay.
Obviously.
Next question. Can you describe a sunset on a flat Earth? Does the sun get below the observer's feet? Yes or no?
I believe we did that one, and I said no.
Yeah, you're up to the one from Geist View.
Oh, okay.
I'll read it. I'll read it. Newton equals the what? The why. Launch a GPS satellite is Newton. Its function is Einstein. So the way they launch a GPS satellite is through Newtonian physics, but it's a function of Einstein in the GPS satellites because they had to make slight modifications to the calculations based on the speed.
Okay. Is that a question?
I don't think so.
More of an observation.
It's a statement.
What number are you at?
Saeed Ahmed, they're not numbered anymore. It's after 12.
Okay, so after 12. Okay, here's 12. So there's Geist View. Okay. So we will define, or that's another statement.
Oh, that's right. From Saeed Ahmed.
Yeah. So we will define or cherry pick our way to flat Earth. Brilliant. I guess we can just read them, just not ask questions. Yeah. Another $2. Stuck in the YouTube matrix, Rachie, as a surveyor, I am insulted. I can understand that. Batman, not FTFE, just to be clear. What is the airspeed velocity of an unladen swallow? That was a question.
Yeah, Rachie.
I don't even know what an unladen swallow is. I'm guessing a swallow is a bird, but I don't know what unladen means. So I'm guessing it's a stupid question or a silly question.
Oh,
I think your next question should be African or European.
African or European.
Nailed it.
Okay. Again, this is from Batman, not FTFE, MCToon. I have spoken to my lawyers. You need to stop telling people that you are me.
Look, has anybody ever seen me with Batman? Proof.
Nope.
I have not.
Total proof.
So I thought I was the only person in this community that had legal problems that needed to be dealt with via.
I'm not worried about fake Batman's fake lawyers.
Yeah.
As if there's a Scottish Batman.
With bagpipes. Okay. Rachie, what is the cause of your attraction between masses demonstrated in the Cavendish experiment? What is your?
That's what I would love to know. I would love to know that. I asked Blue Marble Science, but he couldn't tell me.
I'm sorry. So you don't know why the masses attracted each other?
It's mass attracting mass. That's why. Because mass attracts mass in our Newtonian reference frame.
Right. But Rachie, your answer is you don't know.
I don't know. No.
Okay. All right. This isn't directed at anyone in particular. Why cite NASA when NASA always lies? Except when it does. Except
when it doesn't.
Oh God! Use proper grammar, people. By the way,
she's Dutch.
It's from Dora. Photoluminescent does to cosmic rays instead of direct. I don't know.
I think Dora read. I think Dora read Rachie's citation on the sun, the moon emitting light, and it's photoluminescence due to cosmic rays. Not that the moon is like self-illuminating. That was the thing. The question is important to Rachie. Why would you cite NASA when we constantly hear NASA always lies?
Oh, okay, I get it. Okay.
Did Rachie leave?
Are you still here?
She's still here, but her camera's off. Messed everything up.
But if
Craig's like, what do I do?
Yeah,
Yeah.
she's like, I don't know if her phone's died or something, and it's still showing her as in the call, but I'm not getting any audio from her or any video feed anymore.
Okay. Well, dude. So,
I guess I'll read. There's some more.
I can read them. I maybe because I can go a little quicker.
Well, this is for you.
Oh,
Batman or Superman?
There we go.
Sorry, battery died.
Obviously, Batman. Who's asking? That's a silly question.
So, for Rachie, since you're back,
Fight me, Toon.
if the moon is photoluminescent, like how do you I'm going to just paraphrase. How do you account for the shade in the craters? I guess is what I was going to say.
Not sure. You'll have to ask NASA. They're the ones saying it's luminescent with no sunlight and earth showing.
But the luminescence is photoluminescence from cosmic rays. NASA is not saying what you want them to say. They're not saying that the moon is self-illuminating. That's what we're seeing. NASA agrees that the sun is what is illuminating the moon, but that it also has some very slight photoluminescence from cosmic rays, not just self-illuminating.
So self-illuminating from the cosmic rays, not from the sunlight, basically. Like
no, definitely from the sunlight. And additionally, a very, very small amount from photoluminescence due to cosmic rays. But that they are not saying that the sunlight isn't directly illuminating the moon. That is absolutely not what they're saying.
They're saying it's illuminating when it's not directly in the sunlight, shall we say, and in the earth showing.
Well, it would always be photoluminescing because there's always cosmic rays hitting it from all directions. But
so like when you were a kid and you had like glow in the dark paint, that doesn't mean that was its own source of light. It was glowing based on something that had charged it up prior.
Bioluminescence, right? The chemicals
inside of it. Similar.
Yeah, similar.
Yeah. Well, it's not bioluminescence. That's storing energy and emitting it later. Photoluminescence is converting cosmic rays to visible light.
It's still self-illuminating, still not the sun literally lighting it.
It's not saying that the sun is not illuminating it. It's saying in addition to the sun illuminating it, there is some small amounts of photoluminescence.
No, because it says when the earth showing and the sunlight isn't on it. It specifically says that, demonstrating when it's not in the sunlight and not in earth showing. Specifically says that.
Okay, so the paper does agree that the sun illuminates the moon.
Yeah, but it also says that it glows in the dark and that it's got luminescence not in the sunlight and not in the earth showing.
And so how does that disprove the sun shining on the moon? It doesn't.
It doesn't disprove it, but it shows that it should glow in the dark and that it should have its own luminescence, and that the new moon should be lit because of this glow in the dark. And how much,
and at what quantity of light should be output?
No idea.
Okay, so you can't say, if you have no idea, you can't say how light the moon should appear because you don't know how much. You didn't get that data from the paper.
No, right. I'm not sure if it was even in the paper, but no, I didn't read it all, so no.
Did the paper did the paper say that the moon produces its own light?
Yeah, technically, because of the cosmic rays when it's not in the sunlight and not in earthshine. So if it's not from the sunlight and it's not from earthshine, then technically it's downlight, right?
No, you spoke really fast and didn't answer my question.
Sorry. If it's not in the sunlight and it's not in from earthshine, then it's not from the sunlight because it's not the sunlight, and it's not from the earthshine, which is specifically what it says in the paper. Then obviously it says technically the cosmic rays. So the cosmic rays self-illuminate it.
Well, the paper's been posted in the chat, so people can have a look to see if it says what you want it to say.
What it does say.
Sorry. What number were we at? 7?
I can read it. The Logical Hillbilly. The question is for both debaters. If a dog eats, it's from the Logical Hillbilly. Yeah. If a dog eats and goes in the water, does he get the cramps?
No idea. If a dog eats and goes in the water.
I don't know if it's in England, but here, mothers for a long time have been telling kids that if you eat and then go in the water, you'll get a cramp and then drown. Which certainly is not true. So I would say that when a dog's mom tells a puppy, don't eat and go in the water because you'll get cramps, that also is not true.
Sounds about right. I agree with you.
I remember that when I was a kid, I used to have to wait like 30 minutes and we were always so mad. It wasn't even true.
No. All right, here's one from Debate Night, $5 super chat to Rachie. If relative density disequilibrium is the reason for gravity or the downward acceleration, why doesn't the Cavendish stay stationary?
Well, the Cavendish isn't really RDD, but there's something acting on it. The question is, what is it? I have tried to ask Blue Marble Science what force was acting on it under Newton's first law.
He would say it's gravity. It's mass attracting mass.
But he didn't even say it was gravity. He just says, well, he didn't really give the name of the force. I said, what was the force? And obviously gravity isn't the force, so he couldn't say that, could he?
In our, like I showed, in our Newtonian reference frame, it emerges as a force, like centrifugal force. Centrifugal force is the result of conservation of momentum. It's not actually in and of itself a force. In a similar way, it's emerges in our reference frame as a force.
But centrifugal force is caused by a force.
No, centrifugal force is a result of the conservation of momentum, which is not a force.
Yeah, it's an emergent force.
Yeah.
Caused by rotation, which was caused by force.
I mean, you can go down the infinite regression, of course.
Yep, exactly.
But we just
but
need
you have to in order to find out what the cause was.
Yes. Yeah. Mm-hmm. So Geistview said we missed something from him. Newton said what? Newton equals the what? What did I miss? I don't know, Geistview. I don't see that.
I do know that Newton did say something about but I don't know with reference to what he's saying.
Yeah. All right. I guess we can move on. I will see if I can find what he's talking about. Or Geistview, send me on Twitter. I'll get it. Go ahead, Cliff.
Let's see. Okay. Let's see.
It's for me from FTFE.
Yeah. Saeed Ahmad said, so we will define or cherry pick our way to flat Earth. Brilliant.
Oh, you went way back. I'll read them. Okay, how about that?
Oh, did I go too far back?
I'll read it. I got them. From FTFE, for MCToon, how much wood would a woodchuck chuck if a woodchuck could chuck wood? Well, a woodchuck would chuck as much wood as a woodchuck could chuck if a woodchuck could chuck wood. That's easy. Let's see. We got a question for MCToon. Can you briefly explain the radio telescopes needed for the Apollo missions? I cannot in detail explain them. They had them in Australia. They had one. They had one in the United States. They had another one, I think, somewhere in Europe. I don't know offhand, but they had multiple radio telescopes to communicate because different times of day the Earth would rotate. Would be out of view of the moon, so they had to have a network of them. How about that? Sorry if I didn't have the details on that. Let's see. We've got down here to Saeed Ahmed. Down at the very bottom here. I'd like to be a Poe and a grifter. Watch which YouTube channel should I start watching? Thanks. From Saeed.
If you'd like to be a Poe, I mean, you can start anywhere because that's where they. They're all still at the beginning.
Red Pill Philosophy was pretty good. A lot of people think he was top notch. His channel's gone. Maybe you can find an archive, Saeed. C. Mitch Play says, Rachie, what's the 5 zeros from? And you answered that already.
We already went through that.
She can answer again.
Okay.
Just basically, I tried to type in Rachie, it was taken. Tried different things, it was taken. Tried 5 zeros, it wasn't taken, so I had it.
Well, how about Rachie is awesome? Was that taken?
I didn't try it.
Oh,
I think I tried MC Rachie, but it didn't work.
They just think you're Scottish and call you Mick Rachie.
Well, that's what I was doing with you, but too.
Yeah.
MCToon.
So I guess for Geist View, I already read whatever he was.
Oh, we got a different one here from that FDFE got. So Rachel, your bottle observation is false. You are outside the bottle looking through. You're not outside the atmosphere. You need to account for the glass.
Okay, but wouldn't glass add to the refraction?
Depends on the direction. Depends on the angle of incidence that the light hits the glass. And the index of refraction of glass is around 1.5 to 2.2. The index of refraction within a gradient inside the water there would be quite a bit less.
Okay, well, I had it outside the glass. I lifted it up, lifted it down, tilted the angle of the camera, everything, and empty bottle, full bottle, half-filled bottle, water, sugar, whatever, salt. Did it, and yeah, still always down.
All right. I guess we're at the end of the question, so I'll just ask one.
We're not. I jumped down there.
Okay.
We have more. We've got, let's see, 14. Question to both. How do you decide if the source is reliable, reputable, or should be discarded? What is your criteria?
For me or for you?
It's to both of us, so you could start.
Okay, so for me, if it was credible, it was something that you can basically verify and demonstrate and is repeatable. If it is, then you can verify it. If you can't verify it, then you've basically just taken it on faith, aren't you?
All right. Well, that includes everything on my my site mctoon.net/g. Thank you. But so yes, I agree. If it's something that's been well explored, it's not necessary that you absolutely be able to do it yourself, because if that's the limit, then we can only get so far in science. Once we reach the limit of any one person's ability to do something. So you need to work with other people, and people need to pool their resources in order to do some more of the more complicated and challenging experiments and observations and things like that. So I don't have the money, and very few people would have the money to build themselves a gigantic telescope. You need to have people pool together their resources. But I then can't go and just walk into some telescope myself, right? If I wanted to, I could become an expert in that field and rise my way up into there and say, look, my goal is to be in that particular telescope and be the leader of the field. Anybody can do that. But it's, you can't do that for everything. People have to specialize, right?
And I would ask each of you, could you be wrong?
Absolutely.
Yeah, I think everybody can. We're human. We make mistakes. anybody can be wrong. It's proving that you're wrong, isn't it? And then you can say, I was wrong because I was proven wrong, so I know I'm wrong. Until you know you're wrong, you can't say you're wrong, can you?
So, there could be a globe.
Could be.
Oh yeah, if you show the evidence, yeah, and like there was evidence of it and it was indisputable, and then yeah, if there was evidence, then yeah, it could be. If you're wrong,
yeah, and I believe the Earth could be flat. I mean, there's a mountain of evidence that needs to be overcome, but I think MCToon would say the same, that it could be.
But I tested it.
I don't know how we would get there, but it could be.
I tested it, and it's been falsified many times. Like the map that absolutely must be the one that I explored earlier. I don't think it's reasonable to think that map would work, and that the actual Earth undulates underneath us during the day without noticing. And that's an absolute necessary map.
Right. I mean, we would have to overcome a whole lot of things that we know to be true, that just so many things that we know to be true would have to be falsified. But I guess maybe could be. You have to show the science supporting that. Right.
Yeah. All right. I got a super chat here. It's I ask it sometime. Rachie, where in the globe did math hurt you? It's not very nice, but
it's not. I've asked that question.
Did not hurt me. Math did not hurt me, but the thing is, you need evidence, and without the evidence, you can't say what it is, can you?
Absolutely. Aaron Armstrong says, does Rachie believe in a dome-covered plane? That's a good question.
Well, I'd say more or less yes, but not in the way, not a glass dome like some people think of it. It's not obviously going to be made of glass. You know what I mean? It's going to be like a protective layer of some sort that might be penetrable, but it still keeps the gas in and the gas can't get out. But it's not a glass dome like you think of in like The Simpsons or something like.
Okay. So I guess we're pretty much done with the debate portion. So I've just got a question, because this came up in a video earlier, because I was looking at a video from CC Chris from New York, Westchester County, talking about at the holidays, going to the family dinners that we all have. How do you deal with being a flat earther at family dinners?
Well, it's fine. Like when I talk to my family about it, like for instance, I'll talk to my mom about it or something, and my stepdad, and I'll be like talking about planes, for instance, and the way that they don't drop the nose and things, and they'll like agree with me, and they'll be like, that don't necessarily think it's flat, they don't necessarily think it's round, they don't probably really care, but like they can understand where I'm coming from. And when I actually told them about gravity being embedded in space, they actually laughed their butts off. So pretty good, I'd say.
So they had a free buttectomy. What? I mean, if you had a big butt, then you wanted it smaller.
Right. So yeah,
there's a couple more.
Where we go. Okay.
We've got from the Sun Express. Hey, Rachie, how much does your density column weigh while it's falling?
Oh, good one.
It depends on how much mass is in it and the density of whatever it's falling through. So it depends on the force, basically. You have to measure the force is the weight, pretty much, essentially.
Pretty much force is weight? I agree.
Essentially,
pretty much. Yep, essentially. Or exactly. We could say exactly
but
force is
not
weight.
For you, but for me, yes. Like not for Globus.
Absolutely. Force is weight. Weight is force.
Right.
If
it's falling,
In the US, we measure weight in pounds, but newtons is a perfectly fine measurement of weight as well, which is also a measurement of force. They're the same thing.
Yeah, but yours is the opposite direction to mine. Well, mine can be both direction, but yours is the opposite. Yours is an upward force of the normal force. As PhD Tony would say, like weight, because of Einstein, is basically the force required to stop an object from falling. Therefore, it's an upward force, a normal force of the floor.
That's the magnitude. That's not the direction.
Well, he says in one of his videos, what is weight in Einsteinium, because obviously Einstein is in the force, and that weight is the force required to stop the object from falling, from following its geodesic in space.
Yeah, it's the magnitude.
Well, that's what he says.
Not
It's
the
the force
direction.
required to stop it from falling. Therefore, if you stop an object from falling, what direction is the force?
Opposite of its weight.
But it doesn't have weight when it's falling in your model. It's weightless.
Within its reference frame, it's weightless, but outside of
Right.
its reference frame, it still has weight.
So
It's
things
0
falling
G.
aren't weightless in your model.
What's that?
So things falling are not weightless in your model.
Within their reference frame,
So a
They are-
density
they are
tailor should
weightless.
still work in your model then.
no, because
Why?
when it's falling within its reference frame, there is no gravity because it's in free fall. But outside its reference frame, we can see that, and we can see that the forces are equalized.
Yeah, that makes no sense to me.
I understand.
I don't know why not, because if when something is in free fall, the downward force is equalized with the force that's opposing it, which is the friction.
Okay, so in a
It's one of the
vacuum, let's
forces.
say, what force is opposing it then if it's in a vacuum and falling? There's no force opposing it then, is there, in your model? It's just falling. There isn't even a force on it at all. There isn't even a force of gravity on it. So,
It's accelerating. There's a force on it. It's
Right.
still accelerating.
but gravity's not a force.
Oh my God.
It's apparent acceleration.
Clearly, mass attracts mass. And according to the citations I went over earlier, in our Newtonian reference frame, it's a force. It emerges as a force. So, all right, this super chat here was read wrong. If a duck eats and goes in the water, does it get the cramps?
No.
That's so if the mommy duck talks to the ducklings, is it going to quack? Don't go in the water yet. You're going to get cramps. Anyway, so it's the logical hillbilly corrected that, said it was a duck, not a dog tune. Don't miss this one. Haha. Why are the home economics teachers divorced? What?
No idea.
I have no idea what he's talking about. Hold
I
on.
don't either.
Home. Oh, somebody
Home.
expanded it. Why are all the home EC teachers divorced? I have no idea.
Home ec,
Home
home
ec.
economics.
Oh, yeah. At I don't know the logical hillbilly. Why at your school were they all divorced? At my school, I'd have no idea if they were divorced or not. I didn't know them that well.
Me neither.
All right. Let me see if there's any that Rachie, I saw your your RDD stuff.
Yeah.
And you basically you put in 9.8. You just put it in, which is the downward acceleration, the magnitude of the downward acceleration. The Newton's law of universal gravitation predicts that particular value. So the challenge to you, to RDD or whatever, is to actually output the 9.8 meters per second squared instead of just plugging it into the equation.
No, it's experimentally kind of verified. Like, as in you can
it
see the
is.
gravity. Yeah.
It is, but the universal law of gravitation predicts that value.
But then you've got to say where you got the mass from and where you got the R from, like the distance between the center of the mass and the surface of the planet that you're meant to be standing on, and
Yeah,
as well as big G.
Which have been measured.
How did you measure the mass of the Earth?
Well, Cavendish did that.
Cavendish measured the mass of the Earth.
Yeah, he set out himself. He set out to measure the density of the Earth, and as a side effect, he got G and he got the mass of the Earth.
Right.
Yeah, I don't think you can get the mass of the Earth. You're gonna have to like run me through that because I don't see how you get that.
Go look at what he wrote, or look at some commentary on not what he wrote, what he did. Look at some of the commentary on it, because if you want to get the gravity of the Earth, the density of the Earth, you need to know its volume and its mass.
Yeah, there's tons of experiments that have determined what R is.
Yeah.
I mean, within the last couple of weeks,
measurements,
there's been people who have determined
the radius.
I disagree with that.
It's not that hard.
In your opinion, but I disagree.
So Geistview is asking Rachie, why does a bucket get heavier when you fill it with water, but the density of the water doesn't change, even though its mass does?
Because density is not the weight. Density, like the weight is the volume, and basically, if you're saying that density is the weight, then you're basically saying that the rest of the mass doesn't matter because you're only using the unit per unit volume instead of the whole volume. Obviously, the whole mass matters when you come into weight. You know what I mean?
I don't know what you mean.
Well, if you use the density mass per volume, then you're ignoring all the other volumes. So it's like me saying, I'll just take your arm off and that's your weight. Well, no, because I'm ignoring all the rest of you. So it's the mass is the weight, like not the density.
Mass, weight, and density are all related, of course, but
related, but the density is not the weight. If I says your
Correct.
density is your weight, that's wrong. So
correct, yeah. Neither is the mass the weight. They're different.
Yeah, it's mass times acceleration, but
yeah. All right. Now I think, Cliff, we have gone through.
Yeah, I think we have. So which one of you wants to do your closing first?
I'll go first, unless you want to, Rachie.
you can go first.
Okay. Thank you, Rachie. It was a good talk. I'm glad we finally got to talk. And I hope that you look at some of the things I have, and if you have questions, I'd be glad to answer them. Everybody else, I like I said, I'm part owner of this channel, so be sure to click the subscribe and the bell. And we will be back in 2 weeks with a debate on whether or not parents should tell kids about Santa. And it is 2 elementary school teachers that are debating each other on this. I had no idea they were talking today, and I'm like, oh, that's perfect. So that's in 2 weeks. I have on Tuesday myself on my channel, MCToon, 2 debates lined up for myself. The first one is a super nice guy from Australia that thinks the earth is flat. Craziness, I know. And the second one is a super rude guy named Alex Morales. If you're on last Tuesday, he popped in. He said he's going to be civil, which means he's probably not going to be civil. Anyway, that's what I've got coming up. Rachie, thanks a lot.
Okay.
To you.
Yeah,
Yep,
and yeah,
Rachie's turn.
I know. I'm just going to introduce her. I was pleasantly surprised, Rachie, because I expected to have to intervene a whole lot tonight, and then luckily I didn't have to. So I disagree with you, but thank you for being cordial. And so do your closing, please.
Okay, well, thanks for having me on. I can be cordial. Sometimes I can get a bit heated as well. Me and FTFE sometimes butt heads, but yeah, thank you for having me on MCToon and Schrodinger's Cat. It's been a pleasure, and I will look into some of the things that you've mentioned. Also, if you could, I'll look into it myself, to be honest. The linear thing. So, but yeah, thank you for having me on. I've enjoyed it myself, and yeah, it's been good talking to you.
Do you have anything coming up on your channel that you want to plug?
A few things, but I haven't got them out yet, so I'm not gonna plug it yet.
Okay. Well, I guess that that'll do it. It's funny because one of my very first debates, I think, in my entire lifetime was whether or not Santa was real, and I was on the side of Santa was real. So we'll see.
How you 6?
I was probably somewhere in that vicinity, 6, 7, 8 years old. I was convinced I could not be wrong, which kind of when I debate with people now and I ask them, can they be wrong? And they say no. I think back to those days and I'm like, I couldn't have been wrong. Like I knew for a fact Santa was real. So it kind of gives me a little bit of sympathy for people that I debate with nowadays. But yeah, moving forward, anybody else got anything they want to say? FTFE, are you still around?
Yeah, of course I'm around. I'm the one running the show.
I know.
Yeah, I'm definitely here. Yeah, I'm running the show. Yeah, that was awesome. I very much enjoyed being on the outside of that, listening in. I did want to scream several times, but it was a good job. I was muted.
Yeah, me too. It's tough. I sympathize with you when you used to moderate my debates back in the day.
Yeah. Tomorrow I've got a debate with Kenny Holmrickson, who's been going on with me for a while. And then new episode of Flirty Idiots probably 3 or 4 days after that. And then I'm going to take a few days off for Christmas, then come back with a end of year special.
All right. I guess nobody else has anything. I mean, I'm coming off of a gigantic victory from a copyright strike that I won when the guy said that the video was never going back up on my channel, never ever going back up on my channel, and my channel was going to be gone within 2 weeks, and that was way more than 2 weeks ago.
And the channel and the video's back up.
The video's back up as of last night. I danced on his grave about 4 hours ago. And he said that the video will come back down after the Connecticut Circuit Court responds to it, in spite of the fact that the Connecticut Circuit Court has nothing to say about it, and because it would be a federal case, not a state case. So he's going to the wrong court to ask for the video to be taken down. So I will dance on his grave once again. Frauditors, learn the law, please. Just I'm begging you.
Cool. Well, thanks everybody. Somebody just said there's a Falcon 9 launch in 30 minutes. Rachie, go watch that.
Oh,
go watch it.
It's fake.
I know it's late.
No, it's
Fake.
It's fake. It's fake. They're faking it, Rachie. It's not real.
Land it in the sea.
It's lights in the sky.
All right. Well, that's it. Thank you, everybody. Be sure to come back in 2 weeks, and we'll see about Santa.
Yeah.
All right. Craig, you can take us out. However you do that. Be sure to dance your 70s dance, people.
Good night, everybody.
Good night.
Looks like he's switched to it already.
Yeah, just give it 30 seconds. Groove away. Good night, everyone. Share with all your friends.